Hey, Miriam. All right, so up here I've got the two problems that you had. Page 297, number 22, and number 24. So before we tackle these problems, we've got to make sure that we understand this rule, okay? And if you look in your book on page 294, this rule is called the rational exponent property, okay? So whenever you have a radical, okay, you have this radical where the index is b, and then you have the coefficient inside the radical raised to a power, then that equals x raised to the power of a over b, okay? This is something you need to know because we're going to use this in order to solve these two problems. Okay? So let's start with number 22. So we have 5 times the cubed root of x to the 5th. So how can I write the cubed root of x to the 5th using this property? Well, I can rewrite it as 5 times x to the 5 over 3 power. Okay? You see how I did that? Using this property, I turned the cubed root of x to the 5th into x raised to the power of 5 over 3. And that is divided by, how do we change this using this property? Well, that would be x to the 3 over 5. Okay? So then all we have is a division problem. All right? So I'm going to rewrite this guy down here where I have 5 times x to the 5 over 3 divided by x to the 3 over 5. All right? And when we divide coefficients, okay? Well, I'm sorry, variables with an exponent, and we divide it with another variable with an exponent, the way we do that is we subtract the exponents and we keep the variable. Okay? So, for instance, if I have x to the 6th divided by x cubed, that's going to equal x to the 6 minus 3. I subtract the exponents. So, x to the 6 minus 3 equals x to the 3rd. Okay? So, I'm going to use that same principle with this. All right? So, I have a 5 here, and this is actually a 1, right? It's an invisible 1. So, with the coefficients, we divide the coefficients. 5 over 1 equals 5. Okay? So, I've got 5. And then I've got my x. I'm going to have an x to the 5 over 3 minus 3 over 5. Okay? All right? All we did is we divided the coefficients, and then we divided the variables. And the way we divide variables is you keep the variable and you subtract the exponents. Okay? So what is 5/3 minus 3/5? Well, that's just a fraction problem. So 5/3 minus 3/5, we have to get a common denominator. The common denominator is going to be 15. All right? So I multiply this guy by 5 and this guy by 5. I'm going to multiply this guy by 3 and this guy by 3. So 5 times 3 is 15. 5 times 5 is 25. Minus 3 times 3 is 9 over 3 times 5 is 15. So I have a common denominator. So 25 minus 9 is 16 over 15. So this equals 5 times x to the 16 over 15. Okay? Now we have to rationalize this. All right? So the way we do that, remember, we're now going to work backwards, right? So this guy right here is our index, and this right here is going to be our exponent. So this actually equals 5, the 15th root of x to the 16th. Right? Hopefully you understand that. Okay? Now, can we do even more than that? Yes, we sure can. Because we can factor this guy, where I have 5 to the 15th root of x to the 15th times x. Well, what is the 15th root of x to the 15th? That's just x, right? So that's going to equal, I'm going to take this guy out. That's going to be 5x times 15 root of x. And that is your answer. Okay? So we have, we got here, and then we've got to work backwards now, because we have to rationalize it. Okay? So as we work backwards, the denominator is the index, and the numerator of the exponent is the exponent underneath the radical. Okay? And once you get x to the 16th, you can factor it where you have x to the 15th. What you're trying to do is get a factor that has the same exponent as the index. Because if you have the same exponent as the index, then that equals the variable. For instance, if I have the cubed root of x cubed, well, what does that equal? Well, that equals, using our property up here, x to the 3 over 3. Well, what's 3 over 3? It's 1. So that's x to the 1, which also equals just x. So if you have the exponent underneath your radical equal to the index, then the answer is the variable. It's just x. Okay? So that's why I divided this up, or separated, factor it, from x to the 16th power to x to the 15th times x. Because when we multiply when I multiply x to the 15th times x, which is x to the 1, when we multiply exponents, we keep the variable and we just add the exponents. Right? So when we multiply, we add the exponents. When we divide, we subtract the exponents. Okay? Hopefully that helps you. So let's use what we just learned there. I'm going to erase this. Let's use what we learned here. So number 24, I've got 2 times the cubed root of x squared. So let's write this over here so we got more room. So 24. We've got 2 times the cubed root of x squared over 3 times the square root of x. Okay? So how do we rewrite the numerator using this property here? how do we rewrite it? Well, that would be 2 times x to the a over b, so the 2 over 3. 2 over 3. Okay? Divided by 3 times x. All right? When you just see a square root, there is a invisible 2 there. When we just see an x, there's an invisible 1. So the square root of x is the same thing as 1 over 2. X to the 1 over 2. All right? So now, what we need to do is we just need to divide these. Well, the coefficient 2 over 3 just equals 2/3. I can't reduce that anymore. The variables, I've got x and I've got x. So that would be x, 2/3 times x to the 2/3 minus 1/2. Well, what's 2/3 minus 1/2? Well, let's look at that. It's just a fraction problem. 2/3 minus 1/2. We have to get a common denominator. The common denominator is 6. So what do I need to multiply 3 by to get 6? Well, it's 2. So then I have to multiply the numerator by 2 also. And then 1/2 to get to a denominator of 6, I have to multiply this by 3 and multiply the numerator by 3. So 2 times 2 is 4. 2 times 3 is 6. Minus 3 times 1 is 3. And 3 times 2 is 6. Then we just subtract the numerators. 4 minus 3 is 1. We keep the common denominator as 1/6. So this actually equals 2/3 times x to the 1/6 power. Okay? So now we have to rationalize it. We have to put it back into a radical form. So I have 2/3 times x to the 1/6 equals, well, what is the denominator? The denominator is the index. So that's going to equal 2/3 times the 6th root of x. And it'll be x to the 1, but it's just x to the 1 is x. Now I can't reduce that anymore. I can't factor just x, right? To get that out. Now if I had 7 here, then yeah, I could factor, or I could take it out. Or if it was x to the 6th, then it would be 2/3 x. But in this instance, your index is 6, so it's the 6th root of x to the 1, and the 1 is just invisible. So this is your answer to number 24. Okay? So what's really important is understanding this property. Okay? And again, that property can be found on page 294 in your book, and it is called the rational exponent property. This is the rational exponent property. All right, that's on page 294. All right, you need to know this backwards and forwards. And by understanding this backwards and forwards, then these problems become easier. Okay? Now the other thing that's kind of difficult with these is that we have to learn how to subtract. In some instances, when we're multiplying, we also have to add fractions. So I know some of you guys in class, you don't like doing fractions, but we have to learn how to do them. We have to be able to do them. Okay? So, and once you subtract the fractions, then you have to rationalize it back to a radical form. Okay? I hope this helps you. If you need more explanation or more help, let me know and I'll make another video, and let me know exactly what you need help on, what you're not understanding. I can try and pinpoint that a little bit better, okay? All right, hopefully this helps you. Bye, Mary.